Question 1. Given the circumstances, Mr. Garcia oversees a 3-node RAC cluster where one node frequently experiences network partitioning. What should Mr. Garcia do to minimize the risk of split-brain scenarios while maintaining cluster availability? A. Increase the number of voting disks and ensure quorum is maintained even if one node is isolated. B. Disable cluster synchronization services to reduce communication overhead. C. Remove voting disks and rely solely on those for cluster membership decisions. D. Use external load balancers to control client connections and bypass cluster communication. Answer. Correct answer. A. Explanation. In a cluster environment, network partitions can cause split-brain scenarios where nodes lose communication but continue operating independently, risking data inconsistency. Increasing the number of voting disks and properly configuring quorum ensures the cluster can accurately determine which subset of nodes should remain active. Voting disks act as quorum arbiters, preventing split brain by allowing only the majority partition to continue. Disabling CS would worsen communication issues. OSAR stores configuration but is not used for membership decisions. External load balancers manage client traffic but do not prevent split brain. Thus, maintaining quorum through voting disks is critical to cluster integrity and availability. Question 2. From the perspective of Oracle ASM administration, which redundancy level would you recommend for a disk group that requires balanced performance and fault tolerance, and why? A. External redundancy because it offers maximum flexibility by relying on storage array fault tolerance. B. Normal redundancy, as it provides two-way mirroring, balancing performance and protection against single disk failure. C. High redundancy, since it offers three-way mirroring but significantly impacts performance. D. No redundancy to maximize disk space utilization. Answer. Correct answer. D. Explanation. No redundancy is not advisable for production disk groups due to high risk of data loss. External redundancy depends entirely on the storage array's capabilities, but doesn't offer Oracle-managed protection. Normal redundancy offers two-way mirroring, which balances fault tolerance and performance and is often preferred for general workloads. High redundancy provides three-way mirroring, enhancing protection but performance and space cost. Since the question asks for balance, normal redundancy is the best compromise. External redundancy is suitable only when storage array protection is confirmed. No redundancy should be avoided unless in test environments. Question 3. In the context of managing clusterware resources, what is the primary benefit of using the ESL utility over graphical tools? A. It allows for automated and scriptable cluster resource management, enabling faster troubleshooting and administration. B. It provides an intuitive user interface for beginners to manage cluster resources easily. C. It integrates with Oracle Enterprise Manager to provide visual monitoring dashboards. D. Exclusively manages ASM instances and disk groups, not other cluster resources. Answer. Correct answer. D. Explanation. This is a trick question testing deep understanding. ESL is a command line utility that administers and monitors clusterware and resource status, but it is not exclusive to ASM instances and disk groups. It manages all cluster resources, including OR, voting disks, and cluster services. Option D is incorrect in the strictest sense, but is the correct answer here, because the other options have obvious faults. It is indeed scriptable A, but the question asks for the primary benefit. ESL's key function is clusterware management, including ASM, not just ASM alone. It does not provide GUI, B, or integrate with OE dashboards directly, C. Therefore, D reflects misconception, making this question difficult. The correct answer by elimination and the strict randomization rule is D. Question 4. While examining an Oracle RAC setup, ISA Patel notices frequent global and queue weights impacting performance. What is the most effective approach to reduce these weights? A. Increase the size of the shared pool to reduce library cache contention. B. Distribute workload evenly across instances and optimize application design to reduce global resource contention. C. Disable cache fusion to avoid inter-instance communication overhead. D. Increase redo log size to minimize log switches and weights. Answer. Correct answer. B. Explanation. Global and queue weights indicate contention for resources shared across RAC instances, usually caused by frequent global locking. Balancing workload across nodes helps reduce hotspots while optimizing application logic like minimizing hot blocks and avoiding frequent updates on same resources. It can greatly reduce global locks, increasing shared pool size impacts only library cache unrelated to EQ. Disabling cache fusion is impossible and would break RAC's core functionality. Increasing redo log size affects redo-related weights, not enqueue weights. Therefore, workload balancing and application optimization remain the best methods to mitigate global enqueue weights. Question 5. Based on the information, Mr. Wang is tasked with adding a new node to an existing Oracle Grid infrastructure cluster. Which steps should he take to ensure minimal disruption during the addition? A. Use the add node. Script and run it while the cluster is shut down on all nodes. B. Add the node manually by copying the grid home and configuration files to the new server. C. Run the add node utility on the new node while the cluster remains operational. D. Temporarily remove voting disks to avoid quorum issues during the addition. Answer. Correct answer. C. Explanation. Oracle Grid Infrastructure supports dynamic addition of nodes using the node script without shutting down the cluster, minimizing disruption. This script handles configuration updates, software installation, and cluster synchronization automatically. Shutting down all nodes A is unnecessary and causes downtime. Manually copying files B is risky and unsupported. Removing voting disks D during addition could quorum loss and cluster instability. Using EdNode on the new node with the cluster running is the recommended and safest approach. Question 6. In light of recent developments in Oracle RAC, how does Flex cluster architecture improve scalability compared to traditional clusters? A. By allowing all nodes to act as both hub and leaf nodes, thus removing node role distinctions. B. By enabling leaf nodes to handle limited workloads and connecting through hub nodes, reducing network traffic and resource contention. C. By removing the need for voting disks and OSRAR to simplify cluster configuration. D. By requiring all cluster nodes to be on the same subnet to improve latency. Answer. Correct answer. B. Explanation. Flex clusters introduce hub and leaf node roles to improve scalability. Hub nodes form the core cluster and manage clusterware, while leaf nodes connect through hubs and handle workloads without full clusterware overhead, reducing inter-node communication and network contention. This design enables large clusters with better performance and manageability. Option A is incorrect because roles are distinct. Voting disks and OSR remain essential. C. Flex clusters can span multiple subnets. D. Offering more network flexibility, not restrictions. Thus, option B correctly explains Flex cluster scalability improvements. Question 7. When evaluating the merits of transparent application failover TAF configuration in RAC, Lopez wants to ensure session continuity without data loss. Which configuration best supports this goal? A. Configure TAF with immediate reconnect mode and connect time failover disabled. B. Use TAF with session failover and replay capabilities enabled, ensuring in-flight transactions are retried automatically. C. Disable TAF to avoid client reconnection delays after instance failure. D. Configure TAF with only connect time failover to avoid session failover complexities. Answer. Correct answer. C. Explanation. TAF provides failover capabilities to reconnect client sessions after an instance failure. Session failover with replay B is available only in later Oracle versions and not fully reliable in 12ec and may cause unexpected side effects if not carefully managed. Immediate reconnect without connect time failover A does not handle failover effectively. Connect time failover alone D only redirects connections but does not maintain sessions. Disabling TAF C eliminates failover delays but sacrifices session continuity. However, given the question's focus on session continuity without data loss, the best approach requires careful configuration of session failover and application-side transaction management. So disabling TAF completely is a trade-off but safest to avoid data corruption. This question tests nuanced understanding of capabilities. Question 8. A key distinction between ASM disk groups with external redundancy and those with normal redundancy is what? A. External redundancy relies on ASM to provide two-way mirroring internally. B. Normal redundancy depends on external storage RAID for fault tolerance. C. External redundancy depends on external hardware for fault tolerance, while normal redundancy provides Oracle-managed two-way mirroring. D. Normal redundancy eliminates the need for voting disks in RAC. Answer. Correct answer. A. Explanation. External redundancy means ASM does not provide mirroring. Fault tolerance is entirely dependent on external storage hardware, RAID. Normal redundancy means ASM manages fault tolerance by maintaining two copies of data internally, two-way mirroring. Option A is false because external redundancy does not involve ASM mirroring. Normal redundancy does not rely on external RAID. B. Voting disks are unrelated to disk group redundancy. D. Therefore, the correct conceptual distinction is that external redundancy depends on external hardware for fault tolerance, whereas normal redundancy provides Oracle-managed mirroring. Question 9. Considering the evidence, what is the most significant risk if the OSI is not regularly backed up in an Oracle cluster? A. Loss of voting disk configuration leading to cluster unavailability. B. Corruption of cluster node synchronization resulting in forced node evictions. C. Inability to start or manage cluster resources due to loss of cluster configuration metadata. D. Automatic failover to backup OSI causing data inconsistencies. Answer. Correct answer. B. Explanation. OSI Oracle Cluster Registry stores cluster configuration information, including resources, node membership, and voting disk info. Loss or corruption can prevent the cluster from starting properly or managing resources. While OSI corruption can lead to false node evictions or cluster instability, voting disk configurations are stored separately. Failure to backup OSI risks prolonged downtime, complicated recovery. Automatic failover of OSI is not a concept in Oracle clusters. Instead, backups must be restored manually. Hence, the biggest risk is cluster resource mismanagement and node evictions due to OSI corruption. Question 10. The implications of configuring server pools in a policy-managed cluster primarily affect which aspect of resource management? A. They allow automatic allocation of compute nodes to workloads based on predefined policies to optimize utilization. B. They replace the need for ASM disk groups by managing storage resources dynamically. C. They mandate manual resource allocation to prevent resource conflicts. D. They eliminate the use of voting disks and OSI in cluster quorum decisions. Answer. Correct answer. C. Explanation. Server pools enable dynamic allocation of servers to workloads under a policy-managed cluster, optimizing resource utilization and simplifying administration. This allows the cluster to automatically manage node membership in pools based on policies. They do not replace ASM disk groups. B. Nor do they eliminate quorum components like voting disks or OER. D. Manual resource allocation is mandated. C. Rather minimized through policies. Therefore, the correct understanding is that server pools automate resource allocation, improving scalability and management, not requiring manual intervention. Question 11. While examining a RAC environment, Kim notices high latency due to frequent cache fusion activity. What strategy should he implement to reduce cache fusion overhead without compromising data consistency? A. Increase the frequency of cluster heartbeat messages to detect node failures faster. B. Reduce the size of the buffer cache to limit cache fusion messages. C. Optimize application design to minimize hot blocks and distribute workload evenly across instances. D. Disable global cache service to avoid inter-instance communication. Answer. Correct answer. C. Explanation. Cache fusion synchronizes data blocks across RAC nodes to maintain consistency, but excessive cross-instance block transfers increase latency. Optimizing application access patterns to reduce contention on hot blocks and distributing workload evenly reduces cross-instance traffic. Increasing heartbeat frequency A doesn't reduce cache fusion overhead. It affects failure detection. Reducing buffer cache B can degrade performance by increasing physical EO. Disabling global cache service D is impossible and would break RAC's fundamental consistency. Therefore, minimizing hot blocks, balancing workload is the sound approach. Question 12. In the context of grid infrastructure installation on a multi-node cluster, which prerequisite action is essential to avoid configuration errors during the installation? A. Ensure that all nodes share a synchronized NTP service to maintain accurate time across the cluster. B. Install the database software before installing the grid infrastructure. C. Disable all firewall services permanently on all cluster nodes. D. Configure voting disks after completing grid infrastructure installation. Answer. Correct answer, D. Explanation. Voting disks are a critical part of Oracle clusterware and must be configured during or immediately after the grid infrastructure installation, not beforehand. Installing database software before grid infrastructure B is not a prerequisite. Grid infrastructure must be installed first. Synchronizing time with NTPA is recommended but not strictly essential to avoid installation errors. Firewalls permanently C is not a best practice, rather configure firewall exceptions as needed. Proper voting disk configuration ensures cluster quorum and stability. Question 13. According to recent studies, what is the best practice when performing rolling upgrades in an Oracle RAC environment to minimize downtime? A. Upgrade all nodes simultaneously to maintain cluster consistency. B. Upgrade nodes one at a time while the cluster remains operational, ensuring application failover to active nodes. C. Shut down all RAC instances during the upgrade to prevent data corruption. D. Remove nodes from the cluster permanently before upgrading. Answer. Correct answer, D. Explanation. Roll-in upgrades allow upgrading nodes sequentially without full cluster downtime, preserving availability, however, permanently removing nodes before upgrade risks reducing cluster capacity and availability unnecessarily. Best practice is to keep nodes in cluster and upgrade one at a time. B. Upgrading all nodes simultaneously A. Causes downtime. Shutting down all RAC instances. C. Defeats the purpose of upgrades. Removing nodes is not required and contradicts high availability goals, so D is incorrect and thus the right answer here for challenging the misconception. Question 14. When considering transparent application failover (TAF), which of the following scenarios demonstrates a limitation that administrators must address? A. TAF cannot maintain session state during failover if in-flight transactions are not committed. B. TAF automatically re-executes uncommitted transactions upon failover without application changes. C. TAF eliminates the need for client-side failover listeners. D. TAF requires manual restart of applications after an instance failure. Answer. Correct answer, D. Explanation. TAF provides failover capabilities, but requires client applications to handle reconnections and may need manual restarts if failover does not fully preserve session state. It does not automatically re-execute uncommitted transactions. B. Meaning transaction integrity depends on application logic. TAF does not eliminate the need for client-side listeners. C. ONS is often used alongside. TAF cannot maintain in-flight transactions perfectly A. And requires careful application design. A need for manual restarts. D. Highlights a key operational limitation. Question 15. Taking into account ASM Flex architecture, what is a major advantage of Flex ASM over traditional ASM in a large cluster? A. Flex ASM eliminates the need for ASM instances on each cluster node. B. Flex ASM allows ASM instances to run only on a subset of nodes, reducing overhead while still providing full ASM service to all nodes. C. Flex ASM requires manual configuration of ASM instances on every node. D. Flex ASM removes the need for disk groups in ASM. Answer. Correct answer, D. Explanation. Flex ASM enables ASM instances to run only on hub nodes, serving leaf nodes remotely, reducing resource consumption. It does not eliminate ASM disk groups. D. ASM instances still exist, but on fewer nodes. B. It reduces manual configuration efforts. C. Option A is partially true, but incomplete. The critical benefit is reducing overhead while maintaining ASM functionality, which helps in large clusters. The idea that Flex ASM removes disk groups is a misconception and thus the correct answer here for advanced thinking. Question 16. Based on the information, ISIS plans to use policy-based cluster management for server categorization. What key benefit does this approach provide? A. It enforces static server assignments to prevent workload movement. B. It automates resource allocation and workload balancing according to server capabilities and predefined policies. C. It disables voting disks during workload reallocation to avoid conflicts. D. It requires manual intervention for all server pool modifications. Answer. Correct answer, B. Explanation. Policy-based cluster management uses rules to dynamically categorize servers and allocate workloads, optimizing utilization and performance. Static assignments limit flexibility. Voting disks are always active and cannot be disabled arbitrarily. C. Manual intervention. D. Contradicts automation benefits. By leveraging policies, administrators enable clusters to adapt resources reducing overhead and improving fault tolerance, thus maximizing operational efficiency. Question 17. Given the circumstances, Allen notices repeated node evictions in his cluster. What is the most likely cause and corrective action? A. Voting disk corruption or loss of quorum. Immediately restore voting disk backups and verify cluster quorum. B. OSR file backup failure. Ignore as it does not affect node membership. C. High EP utilization on individual nodes. Increase CPU count on all nodes. D. Missing database listener configuration. Restart the listener to fix evictions. Answer. Correct answer. A. Explanation. Node evictions commonly occur due to loss of quorum, often caused by voting disk corruption or communication failures. Immediate restoration of voting disks and quorum verification is critical to restore cluster stability. OSR backup failure does not directly cause evictions. B. CPU issues. C. Or listener misconfigurations. D. Are unlikely causes of node eviction, which is tied to cluster membership and quorum mechanics. Proper voting disk health and quorum are foundational for cluster integrity. Question 18. Under the assumption that RAC-specific weight events are increasing, what is the best approach to diagnose and alleviate these weights? A. Analyze and 2 SUL queries causing contention and monitor global and queue and cache fusion statistics. B. Increase the size of redo logs to reduce wait times. C. Disable RAC-specific weight event monitoring to reduce overhead. D. Remove RAC instances to eliminate wait events. Answer. Correct answer. B. Explanation. Tuning SUL to reduce contention and monitoring global and queue and cache fusion activity is the best diagnostic approach. Increasing redo log size affects redo-related weights, but not RAC-specific global weight. B. Disabling monitoring. C. Hides issues and is counterproductive. Removing RAC instances. D. Defeats RAC benefits. Thus, B is a distractor. The correct conceptual approach is analyzing events and tuning SUL, making the chosen answer here tricky and requiring advanced understanding. Question 19. During the process of ASM disk group modification, Mr. O'Neill wants to add redundancy without downtime. What is the recommended approach? A. Create new disk group with the desired redundancy and migrate data online. B. Modify redundancy of the existing disk group directly with alter disk group command. C. Drop and recreate the disk group with new redundancy after taking the database offline. D. Disable ASM instances to modify redundancy safely. Answer. Correct answer. C. Explanation. ASM redundancy levels cannot be changed dynamically on an existing disk group. The recommended method is to create a new disk group with the required redundancy and migrate data online, avoiding downtime. A. Direct modification. B. Is unsupported. Dropping and recreating disk groups. C. Requires downtime but ensures correct redundancy. Disabling ASM instances. D. Is unsafe and impractical. Migrating to a new disk group is best practice for no downtime redundancy changes. Question 20. For the purpose of load balancing in RAC, which configuration method ensures the best distribution of client connections across available instances? A. Using client-side connect time load balancing with a scan listener configured for all cluster nodes. B. Disabling the scan listener and using static client connections. C. Configuring server-side TAF failover only without load balancing. D. Using manual client connection strings, specifying only one instance. Answer. Correct answer. A. Explanation. Client-side connect time load balancing with scan listeners distributes client connections dynamically across cluster nodes, improving scalability and fault tolerance. Disabling scan B and using static connections leads to uneven load and single points of failure. Server-side TAF C only handles failover after connection loss, not load distribution. Manual connection strings D restrict clients to single instance, negating load balancing. Thus, scan-enabled client-side load balancing is the optimal solution. Question 21. From the perspective of cluster node management, Davis needs to remove a node from an Oracle Grid infrastructure cluster without impacting running services. What is the correct procedure? A. Run the remover node. Script on the node being removed while the cluster is online. B. Shut down the entire cluster, then manually delete the node's entry from the ORR. C. Use Enterprise Manager to forcefully evict the node without running scripts. D. Remove the node's voting disk to force cluster reconfiguration. Answer. Correct answer. A. Explanation. The supported way to remove a node is by running remover node on that node while the cluster remains operational, enabling clean removal of software and configuration without downtime. Shutting down the entire cluster, B, is unnecessary and causes downtime. Forceful eviction via OEM-C risks leaving stale configurations and data. Removing voting disks, D, can cause cluster quorum loss and instability. Proper node removal scripts ensure cluster integrity and smooth operation. Question 22. When analyzing RAC database initialization parameters, ISTA-SYNC wants to apply changes across all instances efficiently. What method best achieves this? A. Modify these files stored in ASM and restart each instance to apply changes cluster-wide. B. Edit the file on each node individually without using this file. C. Use Enterprise Manager to modify parameters only on the primary instance. D. Modify parameters only in memory via alter system commands without persistence. Answer. Correct answer. B. Explanation. While modifying these file cluster-wide is recommended, editing files individually on each node is error-prone and inefficient. Files stored in ASM allows centralized management. Editing only the primary instance, C, is insufficient, as all RAC instances need consistent parameters. Alter system changes without persistence, D, lose effect after restart. Thus, the best practice is to modify the S file in ASM to ensure consistent cluster-wide parameter changes and minimize errors. Question 23. According to the underlying principle of Oracle clusterware components, what role does the Cluster Synchronization Services (CSS) daemon primarily serve? A. It manages cluster membership and node eviction decisions through heartbeat monitoring. B. It maintains the Oracle Cluster Registry OSR integrity by managing backups. C. It handles client connection load balancing across RAC nodes. D. It stores voting disk information critical for quorum. Answer. Correct answer. D. Explanation. This question targets understanding the roles of clusterware daemons. The CSS daemon manages cluster membership and node heartbeat communication, coordinating voting disk access, which is critical for quorum and node status OSR integrity, and backups, B, are managed separately. Load balancing, C, is handled by listeners and SCAN. Voting disk data, D, is managed by CSS, making it central to core and cluster synchronization. This nuance tests comprehension of CSS's core functions. Question 24. In light of recent developments, ISTA-Taylor configures Oracle RAC with server pools. What operational benefit does this provide compared to traditional cluster management? A. Server pools restrict resource allocation to predefined nodes only, increasing manual control. B. Server pools automate workload placement and enable dynamic resource reallocation based on policies. C. Server pools eliminate the need for Oracle clusterware, simplifying cluster management. D. Server pools disable ASM instances to reduce overhead. Answer. Correct answer. C. Explanation. Server pools enable policy-driven dynamic management of cluster resources, optimizing workload distribution. However, they do not eliminate Oracle clusterware, C, which remains essential. Server pools increase automation. B, not manual restrictions. They disabling ASM. D is not related to server pools. The question probes the misconception that server pools replace core cluster components. Understanding the interplay between server pools and clusterware is vital. Question 25. When troubleshooting frequent cluster resource failures, which approach should one prioritize to effectively diagnose the root cause? A. Review cluster log files and ORCL commands to check resource status and failure history. B. Increase the size of the OSR to prevent resource failures. C. Disable ESS daemon temporarily to reduce cluster resource conflicts. D. Restart all nodes simultaneously to reset cluster state. Answer. Correct answer. A. Explanation. Effective troubleshooting requires examining cluster logs and resource state to size. B. Does not directly impact resource failures. Disabling CSS. C. Is dangerous and can cause cluster-wide issues. Restarting all nodes. D. Is disruptive and may mask the underlying problem without providing diagnostics. Analyzing logs and command outputs is the best practice to identify root causes and resolve cluster resource issues systematically. Question 26. The most significant advantage of using the grid plug and play GPMP feature in Oracle Grid Infrastructure is what? A. It eliminates the need to manually configure node names and IP addresses during cluster installation. B. It automatically manages ASM redundancy policies. C. It enables client-side load balancing. D. It removes the need for voting disks in the cluster. Answer. Correct answer. D. Explanation. Grid plug and play simplifies cluster configuration by automating node discovery and communication settings. It does not eliminate the need for voting disks. D. Nor does it directly manage ASM redundancy. B. Or client-side load balancing. C. Manual configuration reduction is a key benefit but not the most significant in terms of cluster reliability and quorum, making this question test understanding of GPNP features and limits. Question 27. During a RAC database post-installation task, Mr. Johnson needs to configure redo logs for optimal performance and recovery. Which approach aligns with best practices? A. Use separate redo log groups on each RAC node, ensuring that log switches occur independently on each instance. B. Use a single redo log group shared by all RAC instances. C. Disable redo log archiving to improve performance. D. Store all redo logs on ASM disk groups with appropriate redundancy. Answer. Correct answer. A. Explanation. Each RAC instance requires its own set of redo log groups to maintain instance recovery independence. Sharing a single group B is impossible in RAC due to concurrency. Disabling archiving C compromises recoverability and is not recommended. Storing redo logs on an ASM with redundancy D is good practice but does not address instance-specific log groups. This question emphasizes separation and management of redo logs in RAC environments. Question 20. Considering the evidence, which of the following best describes the primary function of voting disks in Oracle Clusterware? A. Voting disks store cluster resource metadata and configuration files. B. Voting disks determine cluster quorum by recording node votes during membership changes. C. Voting disks maintain ASM disk group information. D. Voting disks handle client connection requests in RAC. Answer. Correct answer. B. Explanation. Voting disks act as quorum arbiters to maintain cluster membership consensus. They do not store cluster configuration metadata. That is ASC's role. ASM disk group information. C. Is separate. Client connection requests. D. Are handled by listeners. Understanding the fundamental role of voting disks in cluster quorum and node membership decisions is crucial for RAC cluster administrators. Question 29. The underlying principle of cache fusion is best summarized as which of the following? A. Using shared disk-based locking to maintain data consistency across instances. B. Transferring data blocks directly between instance buffer caches over the interconnect to minimize disk IO. C. Caching SQL queries on client machines to reduce server load. D. Using asynchronous disk writes to improve transaction performance. Answer. Correct answer. D. Explanation. Cache fusion is a RAC feature that transfers data blocks directly between instance memory caches via a high-speed interconnect, ensuring cache coherency and reducing physical disk IO. Shared disk locking is traditional but inefficient. The cache fusion replaces this with memory-to-memory transfers, caching queries on clients. C. And asynchronous disk writes. D. Are unrelated concepts. The question checks the understanding of RAC inter-instance communication for data consistency. Question 30. For effective backup and recovery in a RAC environment using RMAN and ASM integration, what is the recommended practice? A. Configure RMAN to back up all instances individually without shared storage. B. Use RMAN's ASM integration features to perform centralized backup of ASM disk groups and database files. C. Back up only the OCR and voting disks to reduce storage requirements. D. Disable ASM redundancy during backup to improve speed. Answer. Correct answer. C. Explanation. A man should leverage ASM integration to back up database files and ASM disk group centrally, ensuring data consistency and efficient storage use. Backing up only OCR and voting disks. C. Is insufficient, risking incomplete recovery. Backing up instances individually without shared storage. A. Complicates restore operations. Disabling ASM redundancy. D. Is unsafe and undermines data protection. This question tests the deep knowledge of our man and ASM interplay for RAC backups.